Hello, my name is Mike, and for my final presentation I have chosen the thermal imaging camera, or TIC. As you can see, on the bottom right is the temperature of 102, and that will be exactly where that green dot in the middle of the screen is indicating. Thermal imaging cameras have gained acceptance gradually, just like many other new products in the fire service. While the acquisition of TICs by departments can be a costly endeavor, their numerous uses make the device some of the most versatile tools a firefighter can use. Unfortunately, many TICs are left on the apparatus during fires. The capability of TICs greatly increase the effectiveness of firefighting, making their acceptance and use critical. The concept of thermal imaging is traced back to the 1800s and British astronomer Sir William Herschel. Herschel discovered that the colors below the color red in the visible spectrum are visible to the naked eye without the use of a prism. These colorific rays, now known as infrared rays, are the basis for today's TIC technology. All objects emit energy in the infrared spectrum. The hotter the object, the greater the energy release. The rays of energy exist in a spectrum from low to high. These rays include the following: radio waves, infrared waves, visible light waves, ultraviolet waves, X-rays, and gamma rays. As with many technological advances, thermal imaging technology was developed by military. The technology, originally known for FLIR, forward-looking infrared, was used in the Falkland Wars of 1982 by British soldiers to observe movement in enemy troops. This technology was soon added to military aircraft and widely used in the First Gulf War. Military personnel found that the use of thermal imaging technology gave them the advantage of sight over otherwise zero visibility conditions. The application of thermal imaging technology following the Falkland Wars was expanded in the following progression: 1980s, adoption by European fire organizations; late 1980s, adoption by the FDNY in 1988; mid-1900s, adoption and acquisition by other fire departments in the United States. Thermal imaging cameras. TICs work by dispersing infrared rays, then interpreting what is found at the infrared level in a format that can be easily seen. In low visibility environments, light is blocked by particles such as smoke, fog, and steam. The infrared rays emitted by the TIC go between these particles and determine the relative temperature of an object in relation to their surroundings. As a result, personnel using TICs have a readily available view of the area based on the heat emitted by the object. The majority of TIC units are handheld. New technology, however, allows for the production of increasingly smaller units. This newer technology allows TIC units to be directly mounted to the firefighters' helmets and affords personnel the ability to operate with their hands free. TICs vary depending on several factors such as the following: resolution or pixel count. Resolutions are typically 160 by 120 at the low end and 320 by 240 at the high end. Hertz speed. Signal frequency: the higher the speed, the better. Electronic iris operates in similar to a camera lens, and automatic iris is preferred. Dynamic range. Range of temperatures between the ambient temperature and the highest temperature identified. The wider the range, the better. Temperature. Maximum temperatures identified on display. Some units identify temperatures up to 300, while others identify temperatures at 1,000 degrees or more. Color. Some have black and white displays. Others display various colors depending on the temperature. TICs display use their LCD, liquid crystal display, or OLED, organic light emitted diode technology. The display of the TIC is typically the single largest power draw of the device. Portable TICs use batteries to provide power to the device. Traditionally, these units have used rechargeable nickel-cadmium battery packs, but there has been more recent trend toward using standard alkaline batteries. People are often confused of the difference between thermal imaging intensifying, better known as night vision technology, images intensifiers, or night vision goggles, making the available light and greatly amplify in order to allow vision in low light environments. While people using technology are able to see low light environments to display, do not indicate relative or specific heat. Advantage, disadvantages, and limitations. Just like other firefighting tools, TICs have advantages and disadvantages and limitations. They are not affected by weather, allow firefighters to see in zero visibility, quickly identify the source, especially in overhaul, facilitate victim identification, improve the survivability of interior operations, contribute to the reduction of both firefighter and civilian deaths. The disadvantage will not penetrate glass. They will typically not penetrate water. They may not penetrate steam depending on its density. They will display reflections from surfaces such as glass and water, present a two-dimensional image, which means that the depth perception skills must be developed. Thank you.